It's the next bit I want to talk about. Okay, right. Okay, so I'm going to go straight to examples to explain this. Now, there's a formula in the book, right, that's not in the log tables. Okay, if you want, you can learn that formula, okay, but you still need to be able to set it up the way I'm going to set it up in a minute. So I don't bother with the formula because I just use my SN from a geometric series. It'll make sense in a minute, okay? Right, so just bear with me a minute and we'll look at the two ways to do it, and I'll show you which way I prefer. You save €100 every month, right, for 3 whole years. Monthly rate is 0.2%. How much do you have at the end of 3 years? So the first €100 you put in is going to be in for 3/12 or 36 months. Isn't that right? Would you agree? The first €100 you're going to put in is going to be in for 36 months. The second €100 you're going to put in is going to be in for 35 months. The third €100 you're going to put in is only going to be in for 33 months. Agreed? Until you get to the last €100, and the last €100 you invest will only be in for 1 month. Would you agree with that statement? Okay? Right. Okay, so for the first one, right, okay, you get €100, right, and it's 1.1 plus 0.002 all to the power of 36. That's how much money you'll have at the end. If you just put in €100, that €100 for 36 months, that's how much money you would have. Agreed? The next one, right, if you just put in €100 and left it in there for 35 months, right, okay, that's how much money you would have, right? The next one, oh God, how did I go? 36, 35, 33, and 34, right? Next one, €100, 1 plus 0.002, that would be in there for 34 months, okay? And the last one, you'd only get €100 times 1 plus 0.00002 all to the power of 1, because you'd only get paid on 1 month for the last €100. Agreed? So the total money you would have in your account would be €100, the one that was in for 36 months, plus the €100 plus the interest that was in for 35 months. Okay, sorry, I'll have to go like this now. Plus the one that's in for 34 months. Plus all the way down to the last €100 that was in for 1 month. Okay, so what this is a geometric sequence, right? Think back to sequences and series chapter, right? Okay, this is a geometric sequence, girls, that was written backwards. Okay, so I'm going to rewrite this backwards. So the total money in your account is 100 times 1 plus 0.002 all to the power of 1 plus dot 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 dot, I'll just write the last few, 100 times 1 plus 0.002 all to the power of 35 plus 100 times 1 plus 0.002 all to the power of 36. Right, to find out how much is in my account now, I need to add up all those. Right, okay, so this is a geometric series, right? A is the first term, so the first term is 100 times 1 plus 0.002 all to the power of 1. Or is what you're multiplying it by. So every time to go from here to here, I multiply by 1 plus 0.002. So I'll change that to 1.002. Is that okay? Right? Or that's what you're multiplying by every time. Right? Because it's to the power of 1, then it's to the power of 2, then it's to the power of 3. So you've multiplied by 1 plus 0.002 every time. So R is that, right? Okay, and N is how long it's been in, how many terms you have. You've 36 of them. So you've 36 terms. So in total, to find out what's in the account, use Sn for a geometric sequence, right, which is A times 1 minus R to the power of N all over 1 minus R. Okay, Sn, so the sum to n terms, the sum of all those terms is A, which is 100 times, I'm just going to shorten that to 1.002, times 1 minus R is 1.002, all to the power of n is 36, right, all over 1 minus R, which is 1.002. Okay, and into the calculator with that, you'll find out how much is in your savings. So we go 100 bracket 1.002 to the power of 36. Right, I'm making that out to be €3,736.36. So that's how much you have here in your account right now. So if you put in €100 a month at an interest rate of 0.2% for 3 years, that's how much you'll end up in your account. Sorry. Are we okay? I'll do another one of those now because I presume you're confused as hell. Right. Okay, am I ready to go?
Yeah.
Right, example 2. So, same thing. Alan says 400 every 3 months for 5 years. The quarterly rate is 0.9%, so that means he gets 0.9% every 3 months. Quarterly rate is every 3 months, okay? Find the value of the investment at the end of the period. Okay, so he goes €400 is in the, first off, how many quarters do we have? We have quarters for 5 years. There's 5 by 4, there's 20 quarters. Okay, so there's 20 quarters. So that means he's going to get paid interest 20 times. Okay, so the first 400 there is going to be in there for 20 quarters. So it's 0.009 all to the power of 20. Okay, the second one, I did do that right, 5 4s are 20, yeah. The next one is 400, the next €400 he puts in is only going to be in there for 19 quarters. The next 400 is only going to be in for 18 quarters. And ... all the way to the end, the last 400 he puts in is only going to be in for 1 quarter. So that's his savings for the 5 years. Okay, so if you total all those up, right, okay, you'll end up with how much savings he has. Right, so in order to total them up, right, we need to turn this into a geometric sequence or a geometric series. So we need to write it backwards. So that means I'm going to start with this one. So I'm going to reverse the direction in which I've written it. Okay, to the power of 1 plus all the way, right, okay, 400 times 1 plus 0.009 to the power of 19. I just didn't bother writing that one. Okay, plus 400 times 1 plus 0.009 to the power of 20. Okay, right, that's a geometric series. A is the first term, R is the common difference, or what you're multiplying it by every time, the common ratio, and N is how many terms are in the sequence. So A is the first sequence, which is just our first term, which is 400 times 1 plus 0.009, right? R is what you're multiplying by. So to go each time, you're multiplying 1 plus 0.009. That's what you're multiplying by every time, because it's to the power of 1, then it's to the power of 2, to the power of 3, okay? So I just write that as 1.009, okay? Right, and T is how many terms are in the N is how many terms are in the sequence. N, there's 20 terms in the sequence because it was 20 quarters. Okay, then you get Sn. So Sn equals A times 1 minus R to the power of n all over 1 minus R. Right, okay, filling that in, that's 400 times 1 plus 0.009, that's A. Right, A is that. Then it's 1 minus R to the power of n. So R is 1.009. To the power of n is how many terms you have. We have 20 terms because we have 20 quarters. All over 1 minus R, which is 1.009, into the calculator with that. So we have 400 multiplied by 1.009 by 1 minus 1.009 to the power of 20, close bracket, underneath I have 1 minus 1.009 equals, right, and at the end of his 5 years he has Sn equals 8,889 cents. So that's how much is in the account. Is that alright? Okay, now I just want to discuss something, right? Okay, there is a formula in the book, right? So you can actually work out a formula, and it's in the book, okay? It's on there, but it's not in the log tables. And to be in the exam questions, they often ask you to set it up as a geometric sequence. So I think you're better off ignoring the formula and just going straight for this, okay? Because sometimes they ask you in the question to set it out like this. So if you go straight for the formula, you won't be able to do this. So I think this is easier to remember, right? Okay, and it makes more sense to me. You'll have to think about what makes more sense to you. Okay, because nothing probably makes sense at the minute, but okay. Can I take that away?
Yeah.
Right. Example 3 is working backwards. Right, okay, so it's the same thing again, except now I know how much I want at the end. Okay, so find the sum of money, right, that's P euros. So you're saving a certain amount of money that needs to be saved every month. So every month you're putting a certain amount of money into an account, right, to cover the cost of a $1,500 or €1,500 holiday in 18 months. So you want to save up 1,500 in 18 months. The interest rate is 0.5% per month. Okay, so you know that the first one you put in, the first installment, P is your installment, so the first one you put in is going to be 1 plus I, which is 0.004, and that's going to be in there for 18 months. The next installment, you're going to have interest on that of 70 for 17 months, right? Plus all the way to the end. The last installment you put in will only be in there for 1 month. Okay, so the first installment is in for 18 months, the next one is in for 17 months, the third one is in for, you'll get 16 months interest on it. The last installment you put in, you'll only get 1 month's interest on it. Okay, and when you have all that done, you want to end up with €1,500, right? Okay, so let's write it backwards so we can set up our geometric sequence. So I'm going to change that to a 1.004 in there, right, to the power of 1, plus all the way up to p times 1.004 to the power of 17 plus principal times 1.004 to the power of 18. Okay, right, that's your geometric sequence. A is your first term, which is p times 1.004. R is what you're multiplying by, so you're multiplying by 1.004, right? And n is the number of terms in the sequence, is 18 of them, because there's 18 months. Okay, so then we go, Sn is equal to a times 1 minus r to the power of n all over 1 minus r. Remember, that formula is in the log tables. Okay, Sn is how much I want to end up with. So I want to end up with €1,500, right? The first term is p times 1.004. Then it's 1 minus r is 1.004 to the power of n is 18, right? Okay, all over 1 minus r, which is 1.004. Okay, right, you obviously can't put the whole lot into the calculator, but you can put this bit into the calculator. So just turn that bit, put that much into the calculator. Okay, so it's 1.004 open bracket 1 minus 1.004 to the power of 18 close bracket all over 1 minus 1.004 equals, and when you work all that out, you'll get 1,500 equals p multiplied by 18.6997. So then you divide, right, 1,500 divided by that, right? Okay, so 1,500.
Miss, will you put the screen up a little bit, please?
I will, sorry.
Thanks.
Okay, and it's 80.2149. So it's 80.21, correct, to 2 places decimals because it's money. So that's how much she needs to save every month. So she needs to put in €80.21 in order to have €1,500 in 18 months time. Okay, right, I'm going to give you a few of these to try. Okay, I know they're a bit complicated, so I won't give you too many. So if we just do page 154, let's do 1, 2, 3 and 6. Okay, so page 154, 1, 2, 3 and 6. Okay, so that's me done for the day. So if you want to head off and get them started,